table. One, you look at your inputs and you kind of look at, are these consistent change amounts in your input? If they are, then you can actually look at the output and see how consistent they are in helping you determine what kind of function it is. Now they all go up by 5, so we got plus 5s going around, for the inputs. These are all plus 5, etc. And down below, I don't know, it goes up what, by 3.9 to 4.6.7, and then 4.6 there, that's 4 instead of 0.14, it's a little bit bigger. And then 5.7 to 6.3, and then 6.7 again. If I look at all these changes, that's 0.4. If I did that wrong, just let me know. I'd say on average, if I looked at that, it's not a huge amount of fluctuation. And it's hard to make that call unless you have experience, but that's close enough to consistent as far as a growth. I think that might be a linear function. That might be close enough. I think a linear approximation would be okay. It wouldn't be appalling if I were to do that. So what we're going to do is, first I'll show you how you could do it. Just get 2 points that are kind of close together. It doesn't matter what they are. I'm going to pick, what did I pick before? I picked something different this time. I like variety. So let's go with 20, this point here, and this point here. What I can do is, if you can imagine this as a graph of plotted points, which we will look at, by the way, and I'm trying to find a reasonable 2 points that I could kind of get a slope between, is what I'm shooting for. So that's what this is. I've picked 0, 3, 9, and 20, 6, 7. And you guys remember the two things in a linear equation are slope. So let's make this nice and big. I'll do, what was that, 6.7? I'm doing, yep, 6.7 is the output minus 3.9, the other output. They go on top. Inputs are 20 and, is that right, 20 and 0? Yep, 20 minus 0. So you get your slope. 6.7 minus 3.9 makes for 2 point something. 2.8? No. Yeah, 2.8. You okay with that? Divided by 20? And if you do that, you get 0.14. Hey, what do you know? Not bad. That's a slope. 0.14 for that. That's not the only thing you need in the equation. We tend to like for an approximate linear model, we like the slope-intercept form. We got the 0.14x. We just need a y-intercept, which we usually have to go find sometimes in an equation. Unless, if you're being savvy, you notice that, ooh, we've got something right there. You see that? That is a y-intercept. Any input 0, some number, that's definitely a y-intercept. So I'm going to steal it. It's 3.9. So all I have to do is go down here, say 0.14x plus 3.9. That's it. That's an approximate linear model. A pretty decent one. So I want to get you guys into your calculators a little bit, show you how to do this with the calculator. On some of your desks is a sheet that I'll also load onto Google Plus and my Drive, which I got to make that more available to you guys, which I'll work on. So on Google Plus, what I have to do right now is I have to post a link that says, hey, here's my Drive. You want to bookmark it and you can go there anytime. There's some instructions on these 4 desks, and I'll go get some more. If you hang on just a second. Or you can just figure it out with me here. I think I sent them all out. Es posible. Yeah, I think I gave them all. I can hand out more. If you want to look at a hard copy, you sure can. But this is what's out there. It just gives you all the steps that you are now going to walk through with yours truly. Anyway. But that sheet can be in your hands should you want it. But we'll put this in. So we want to get a graphing calculator out. If you don't have one, you want to let me know. The first thing you want to do is, so you're at the home screen, there's nothing on there. You want to get to something called Stat and Edit. So you hit the Stat button, Edit comes up. Anything you want to do statistically, you start with that Stat button, and then Edit means you can put some data in, is what it boils down to. Thanks. You're very welcome. So Stat and Edit, we're going to go put some stuff in, so I'll click Enter on Edit, and it takes you to List 1 and List 2, and from List 1 and List 2, if clicking works, you put in the X inputs usually in L1 and outputs, or your Y's, go in L2. I already have mine in there, so you can borrow them from there. But what we'll do with that is plot it to take a look at it. So first you enter it, stat edit, just to get it in there. And then we'll do this stat plot thing where we plot the points just to see what they form out to be. Are they straight, curvy? I know you guys are quick typers. Okay. So those are entered in, and it's right from your number 3 problem that you guys have. So I will, once I get them entered in there, so just go ahead and use your sheet. The next piece is, I'm going to turn these off. Okay. I'm going to leave those in there for later. You'll see why. But up at the very top, see that plot 1 that's up there? It's flashing right now. If you hit enter on that, it'll get dark. If you hit enter again, it'll go light like this and flash. Hitting enter turns it on or off. Depends on what it is. It's a toggle switch. If I turn it on right now, plot 1 is on. That's actually, you want to keep track of that. Anytime you're graphing, you want to actually take a peek to see if you have plot 1 on. So I'll go up there, hit enter on it, and now it's darker, and I go down. Should stay that way. Plot 1 is currently on. Well, that's great. You have no idea what it's plotting at this point, but if you can be somewhat confident in the fact that plot 1 is usually defaulted to, it's going to plot what's in L1 and L2 as input and output. To be sure, there's a place to find out. So plot 1, the stat plot thing right above y equals, is the place to go see what plot 1 is going to be. Now plot 1, there's a lot of options. If you guys have had stats and probability, you know about all the cool things you can do. But second and y equals, you go up to the top, there's this plot 1 on, because we turned it on in the y equals. If it says off, you just need to go, we're going to find out how to turn it on here as well. So I'm going to hit enter. So plot 1 is on. And when you hit enter on plot 1, in this context, it gives you a place to turn it on and off. You can choose cool kinds of graphs. You can do histograms. You can do box and whisker plots and connected graphs and unconnected, all kinds of neat stuff. You also get to choose your lists for your input and output, x1 and y1. X and y are in L1 and L2 respectively as a default. Okay, so now we're ready. To get this to show up, to get the plot to look really groovy, you don't go to y equals and hit graph. You actually go under zoom. Zoom is the hub for all things graphing. Like if you want to graph something, you go to zoom. This particular collection of L1, the plot data, there is a thing called zoom. You go down just a little bit further. It's number 9. Zoom, oh, number 8, I'm sorry. Zoom stat, oh, it is 9. Weird. Zoom stat. That's for all the things under the stat window. Like this, we did stat edits to get this data plugged in the lists. So if you hit number 9 or you go up and highlight number 9, hit enter, it will plot whatever's in your plot 1, your L1 and L2. It'll put a little graph in there. It fits the screen. You don't have to do any adjustments. It's beautiful. So I'm going to type 9, or you can click on it. And voila. So L1, L2, and then you hit zoom 9 for zoom stat. Cool. That's part 1. Looks pretty linear. So the same thing I confirmed numerically a little bit ago definitely has a linear kind of bend to it. So now I'm going to actually come up with an equation that will model that using the calculator's beauty and calculating power. How about this time, instead of, we're going to do stat again. Anything that has to do with lists, it's under stat, but we're going to calculate something. So we're going to go stat, calc, and this is to do a linear regression. So once you plot the data, which was stat plot or stat, you want to do stat edits, and we did stat plot, got a nice graph. Now we're going to get an equation to fit it, which is this stat calculate, because we're going to calculate something with the data. And the only reason I say all this is that I don't remember buttons well, but I do remember, okay, once I have data, if I want to calculate something about the data, I need to go stat, go over to calculate, and it lets me do cool things with statistics. One variable statistics, linear regressions, quadratic regressions, etc. But I'm going to go to number 4, the linear regression. You can type 4, or you may go to 4. And it'll print it on your home screen. You can hit enter here. You can also do some other cool things after this, but it defaults to plot 1, L1 and L2 as your input and output. And if you hit enter, it'll give you a nice equation that models what we have. If you remember, the one we came up with was 0.14, and we got something really close to 0.13 for slope. That's good. Our y-intercept was 3.9. This one has 4.0. That's not bad. So we're okay. The next thing is we want to graph the two together. So you have the plot, and then you want to put the line with it. So this is a lot of information, and some of you already know it, and you're great with this stuff. The others, you're going to want to look at that sheet, steal that one, you're going to go download it and keep it with you. It'll be on the drive. You can always grab it. It'll be the intro to kind of linear regression is what it's called, the file that I have. And it's just all the stuff you see on that sheet. Now, I have the plot one on. All of the graphs, other graphs on here, you want to make sure they're off. These are all darkened. The equal signs are not darkened, means they're off. If I go up and hit enter on the equal sign, look what happens. It's got that little highlight on it. But you want those off if you have one, or delete them. Either one's fine. So I'm going to hit enter. It's off. There's a great way to put the regression equation here, and it's not write it on a piece of paper, go to y equals, and then type it. You can actually call it up. It's stored. The regression equation is stored in your calculator's memory. Instant you hit enter on that, it's stored it. And it's a variable. It's stored as this thing called regeq. So we're going to call it up and plan it there. And it's a variable. Anything that's stored in the memory is called a variable. So we go to vars, which means variables, and that's where it's going to be. So stats and edits and stat and calc are places to enter and to calculate on data. If I want to call up the variable known as regression equation, you go to vars. And it's under statistics. It's a statistical variable because it's regression as a statistical operation. It's mathematical, but we tend to think of it as statistical. And it's a regression equation, so it's under EQ, equation. And then you hit wherever you had to be in. Now I'm going to back out and do this again because I had to be in Y3. I have to be at whatever place my cursor is right now. When I hit enter on regeq, it'll print it there. So my cursor is on Y3 so I can have a nice clean space to print it. I'm going to go vars. I'm going to go statistics, which is number 5. I'm going to go equation. And there's a regression equation. If I hit enter, it prints it right into that spot. And it sounds tedious, but once you get the hang of it, you'll get the idea. When we do a lot of regression later on, you'll just go, oh, don't worry, vars, stat, EQ, regression equation, bam, move on. And you guys know how you get better at things over time. And then we hit graph, because the graph button now will graph the same screen we had before. It's just going to add that line that we put in there. And that's nice. It's a good fit. Not half bad. With a lot of stuff in there. But again, you want to have a reference sheet for sure, because hard to remember. All right, back to the business of, we're going to rough one out, one more. So I'm going to go over to my crazy reflector screen. I hope you're back. Be back. There it is. Come back. Mirror again. Come on. Here, buddy. Oh, it came back. Sometimes it doesn't. Okay. And then take off those last two little scratchies. Let's do this. Bottom one. I'm going to do this a little quicker so you can just see. Basically, a model is anything that you can do to make a prediction. So a regression equation is to make predictions about what's in the future or what happened in between. Those go by fives. Your inputs are by 5-year intervals. What happens on the in-between years? A regression, it's a way to make calculation of predictions in those years. Next one, I'll just throw some stuff together. I need a slope, so I think I'm going to choose 5, 10, and let's do 12, 24. That's what I've been using. So for slope, my outputs are 24 and 10, not 20, but 24. So I'll subtract those. And in the same order, subtract the inputs, 12 minus 5. Remember, you got to do the same order. Your y is subtracted, and then do your respective x's. That's a 14 over 7, which is 2. Slope. Now, if we're lucky, we'll have a y-intercept in our data, and we can just put one in there, be ready to go. We don't. So you have to go get another way. And the other way is using one of your favorite things from last couple years. There's a special equation. See if this sounds familiar. I'll tell you where it comes from.